This is video 2 in our series on assessing multivariate outliers. In video 1, I introduced you to the heuristic dataset and ran some initial descriptive statistics to assess for univariate outliers. We also started looking at some visualizations for multivariate outliers and ended with discussion on Mahalanobis D. In this video, we're going to start assessing Mahalanobis D for the whole dataset as well as each individual subgroup, before running our descriptive discriminant analysis. To assess multivariate normality in multivariate outliers, I'll be using the multinorm syntax from Henson 1999. Henson provides the syntax to run the multinorm procedure. What I've already done is I've already gone ahead and typed all this out into Notepad. I'm now going to open up the file, and I'm going to copy this and paste it into my own syntax. First, I'm going to add a comment. Now, before I run it, I have to make a couple of changes. I have to change x and z to my own variables of interest. So what I'm going to do is I'm going to type in research D and love statistics. I will then copy this and paste it here as well. I'm going to change the number to 16 because that's our sample size, there and there. Now I can run the multinorm procedure. So what I will now do is highlight it and run it. The multinorm procedure gives you several pieces of information. It provides a regression that it uses to calculate Mahalanobis distance, to list the variables. The multinorm procedure also produces Mahalanobis distance from smallest to largest for each case, along with the chi-squared. Now looking at this, we can see that case 7 has Mahalanobis distance of 9, which is fairly large, and a pretty large chi-squared as well. Now I'm going to look at the visualization of this. As we can see, we have a nice linear pattern here. They're pretty close together. And then we have this one case which is pretty far removed. And this is going to be case 7 that we saw with Mahalanobis distance of 9 and the chi-squared a little bit larger than 6. Based on the large Mahalanobis distance score of 9.007 and a chi-squared score of 6.93 and a p of 0.97, I know that case 7 is pretty far away from the centroids and is a potential multivariate outlier. As such, I will want to run the DDA with and without case 7 and interpret both results. When I look at the scatter plot of Mahalanobis distance D in chi-squared, with the exception of case 7, the data looks pretty normal. It appears to have multivariate normality. Since this is technically grouped data, I should actually assess for outliers in both groups individually. Before I start assessing each group's Mahalanobis distance scores, what I'm first going to do is I'm going to go into my syntax, and then I'm going to copy this and paste it twice. And I'm going to change the comments. The last one's going to be assessing group 2 only. The first one's going to be for group 1. I'm also going to go ahead and change the Mahalanobis distance. Next, I'm going to scroll down to group 2, and I'm going to change some of the variable names. That way, when I run this, it's not going to overwrite what I've already had calculated. So I'll change this to 2. A couple of locations. I'm going to change P to P2. This way it won't overwrite what I've already have done. Now I'm going to go create a filter. That way the multi-node procedure will be conducted one group at a time. To do this, I'm going to go to Data, select Cases, going to go to click on Role, and then If condition is satisfied. Click on If, I'll move Role to the window, and then click on Equals 1, and then click Continue. This filter is going to filter out everyone who has a faculty or role equals 2 out of the data set temporarily. So I'm going to click on Paste. Now I'm going to take this, I'm going to cut it and move it above into the analysis for multi-node for group 1. And add a comment saying created graduate student filter. And then I'm going to go ahead and copy this along with the comment and put it above the second multi-node procedure. I'm going to change role equals 2 . That way, this will pull all faculty members instead. So I'll change this to faculty filter. I'm also going to go back into Data, select Cases, and click on Reset and Paste. This will turn off the filter. So I can leave that one there. I'm going to go ahead and scroll up and put it here. That way I can clear out this filter first before adding the faculty filter. I'm going to copy that and paste it there as well. Now before I run this, notice how we already have this multi-node procedure. I'm going to add a quick comment saying went into data set and cleared old values. Now that I've added the comment that I've gone into the data set and cleared out the old Mahalanobis distance values, I need to go ahead and do this manually. I'm going to open up my data set. I'm going to click on Y, Mahal 1, P, and chi-squared. These are all printed out by running the multi-node procedure. I'm going to right-click and then select Clear. After this, I'm going to go back and open up my syntax. This way, it's not going to overwrite what we already have from the multi-node procedure. Before we run it, though, we're just going to scan through the syntax really quick, make sure there's no issues. Okay, everything looks pretty good so far. Well, now this typo would have caused several errors, so I'm going to go ahead and change this around. Now without that correction, there would have been a mismatch. So what I'm now going to do is I'm going to highlight all the syntax between those two multi-node procedures for both groups, making sure to include both filters. I'm going to highlight and run. So we'll scroll up to the Mahalanobis distance and multi-node procedure for the first one for the graduate students, and I go past the regression information and look at the first list. Now we have one that's Mahalanobis distance of 9. It's fairly high. Again, these numbers aren't going to match with the participant number because it automatically resequences it. However, it does see these values within the data set. So we'll go down a little bit. We can see that we have a Mahalanobis distance for group 1, one of them with a 9, chi-squared of 6.93. There's a graphical representation. So we can see one is really far removed from the others. This one's a little bit removed. But again, it's a very small sample size. Now I want to check for the faculty subset. See 8 participants. We'll scroll down. we can see that we have Maltobus distance ranging from fractions to 1s, 2s, to a 4. So we have a graphical representation of it. Okay, it looks pretty linear. This one's a little bit further removed as well. So I'm going to go ahead and take a look at the data set as well, where all these values are saved. Now in our data set, we can see that we have Maltobus scores for that filter. So we have just graduate students here. For Maltobus distance 1, Maltobus distance 2, these are the scores for just faculty. You can see this is fairly high, with a score of 5.01 and chi-squared of 6.93. You can see this one has 4.46 with a chi-squared of 6.93. Now recall that case 7 was one that had the Maltobus distance of 9 before, so it's still fairly high. So what I might want to do then is I might want to potentially move case number 7, participant number 7, and participant number 10. I want to run the descriptive discriminant analysis both with those cases and then again without, and then interpret both sets of results. In the next tutorial, we will be running the DDA both with and without these two potential multivariate outliers.